Fraser, we wish you were here in real life. We could use your hands and your brain and your mind, but I'm glad that you are at least here in my Zoom window. How are you doing this evening?
I'm doing well. Clearly a little more relaxed than you are, but then you've been broadcasting for what, 12 hours
I,
now?
I, so true fact, my computer is just barely hanging on over here because the
Oh,
chair I'm sitting in, no, like gravitationally hanging on. The
oh, as opposed to technologically hanging on.
Yeah, no, technologically it's great. Gravity's the problem. So the chair that I'm sitting on, which is a very cheap chair that happens to be very old, um, it decided that last time I stood up from the chair, I put my hands on both arms and pushed out and up. That was a mistake.
I can see the structural failings already. Yeah.
Right.
So, so,
So,
so Nancy is noting, yeah. So when I came back from my hiatus, the first broadcast that I did, my internet cut out because a mouse chewed through my Ethernet cable.
oh my goodness.
Yeah, yeah, live on air. A mouse chewed through my Ethernet cable. That is the level of technology fails that I'm able to bring to the table. So yeah, yeah, I think we've caught 8 of them so far, 9 of them so
Oh,
far.
oh no.
Yeah, yeah. So we've got a bunch of live traps, so it's working okay.
Yeah, yeah. So I have to say that uh getting ready for last year's Hangout-a-thon, um that was done in the basement after realizing that the Hangout-a-thon before that had led to a mouse infestation. So the attic has been thoroughly demoused. They moved into the walls where we listened to them all winter and could not get to them.
Oh, yeah,
But
yeah,
now we have a mouse-free home because they all went out in the winter because not in the winter, in the summer because outside had more food and was cooler than inside the
yeah.
walls.
And then hopefully they couldn't find their way back in.
Well, I'm sure there's still some mice because this is an 1893
Yeah,
farmhouse.
yeah. I defy the mice to try and figure out a way into my new house. The walls are concrete, um, but yeah, it's been I mean, and it's been just torrential raining here for the last
Oh,
couple of days.
geez.
It's just been madness. Yeah, so much rain. Um, like in we've had weeks worth of rain overnight. It's very moist.
Oh, oh
But apart
dear.
from that, we're doing great. We got a dehumidifier that made a big difference. Keep the trailer dry so the condensation is off the walls. Um, it's just like it's funny as you sort of learn all the technology of trailer life to be able to just survive. But we've only got a couple of months, and then we should be into our new studio, which I've been sharing a couple of pictures and videos. I'll share more as we continue to build.
I can't wait. You gave me the opportunity to see your architectural drawings before this all got
Hmm.
started, and as someone who lives in, I wouldn't say it's the opposite of a minimalist home because it is an arts and crafts style home. Our house nonetheless, it does not have sleek lines. It has simply lots of lines
You live in a
and lots of
mansion.
windows.
Yeah, you live in a giant
I
mansion.
live in
Yeah,
a rambling farmhouse.
yeah,
But so yeah, your sleek new modernistic house is going to be the envy of all the kids, especially with your Starlink.
yeah. My our builder called it prison chic.
Now, for all of you meeting Fraser for the first time, I am joined this hour. This is hour 13 of the CosmoQuest Hangout-a-thon 2021 Countdown to Flight. Joining me this hour is Fraser Cain, publisher of Universe Today, and with me, one of the originators of podcasting back in the day when No one even knew what the words meant, and we gathered together through Skype to do, well, discussions with all of us brought together periodically and put out. That was the Slacker Astronomy podcast back then. And, well, we've grown up and we're in season 15 of Astronomy Cast now.
Yeah. 15. It's crazy to think that we've been doing this now for 15 years. Yeah. Yeah. I wonder. It's funny. I talk to people and they go back and listen to like the first episodes. And it's interesting to sort of hear their experience, how things have changed or how they've remained the same. And it's funny how a lot of the things, hello, dog, a lot of the, every now and then the dog shoves the door open to make sure everything's okay.
Yes.
Yeah, just it's interesting to sort of go back. I can't bring myself to listen to an episode of Astronomy Cast, but people who do go back, they say it still holds up. So I think that was the plan from the beginning.
Yeah.
Was that we would make a show that no matter when in time you wanted to listen to it into the future, you could, no problem. So.
And what's amazing is I feel like we've really gotten to grow up with people. Beth Johnson, who is my co-host for Daily Space, which airs Saturday and Sunday nights on Now Media and is recorded live on twitch.tv in front of our virtual studio audience on Tuesdays through Fridays. She started out listening to Astronomy Cast back in the very beginning. She was pregnant with her kiddo when we started. Her kiddo is now a teenager. And
Yep.
and now she's one of my co-hosts after she went back to graduate school and undergraduate and got her science degrees, and heck, she's as good a writer as I am and just an amazing colleague to have, and she's here
Yeah.
because of our show.
My daughter was 4 and now she's attending her second year of university. So
Yeah.
it's crazy.
Should
Yeah.
I embarrass Logan?
He will never find out.
So
He's probably watching some other Twitch.
the first time we'd met was in Austin, Texas for the AAS, and the second time we met, I was in Seattle, Washington. I don't remember exactly why, but you were passing through on your way to Disneyland with your kiddos.
Yeah, we do the West Coast road trip.
Yeah.
Every few years. Yeah.
And Logan was so young and so nervous that he totally wet the bed. So I have known your son since he was so tiny that not
he was
wearing
5,
pull-ups
I
was
think.
yeah.
He was 5 at that point. Yeah.
I'm not sure he was quite 5 yet.
Maybe 4.
Yeah, I think he was closer
he was
to
a little
4.
guy.
He was
Yeah.
tiny.
Yeah.
So I've loved getting to know you, watching your kids grow up, and watching our audience grow up with us.
Yeah, he's 6'3" now and has his own apartment, girlfriend. So yeah, no, it is kind of crazy. And it's funny to think like I know that I've found my career for the rest of my life.
Yeah.
And even the times when I've done other things, like when I was working with Hero X, it's all I can think about is getting back to this job.
Yeah.
And each year that we do both Astronomy Cast and as I work on Universe Today and just get better and better and better, I just enjoy the mastery of doing this work and finding my life's calling. It's been an absolute honor to keep doing this work.
And Universe Today is something you started in what, 1996?
99.
99. Okay.
Yeah. Yeah.
Just flipped the digit upside down. That's a thing I
Yeah.
do.
So I think we're what, 22? We'll be 23 years in March.
So you're old enough to drink in the States, but not to rent a car.
Right. Yeah. Universe Today.
Yes.
Can't rent a
Universe
car
Today.
yet, but it can drink. Yes.
And
Yeah.
and for everyone out there who hasn't somehow stumbled across your amazing website yet, what all does Universe Today put out?
Well, so we have about, I'm going to say we have 20 writers-ish around the world. many of which have PhDs
Yeah.
in astrophysics, astronomy, cosmology, and we report on space and astronomy news that's happening around the world, from NASA news, of course, that's happening in Europe, China, Japan, and but it's still a very small operation. I mean, it's a fairly big team, but it's very lean. You know,
Mm-hmm.
the entire company has always been run from my kitchen table. Of course, now it's run from my trailer's kitchen table. Sometimes I sit in my car to do the work, um, and but really the goal is to go and find this, like, try to walk that line between being as scientifically accurate as we possibly can, but also help people just understand how interesting and fascinating this stuff is. And um, yeah, it's it's been going great. It's funny. University is doing better now than it ever has been in the history of that I've been running the website. Even through the pandemic and everything.
And one of the best pieces of career advice you ever gave me was actually one that you probably didn't even realize you were giving me at the time. And you said that if you want to hire really good people and you want to hire a diverse staff, offer part-time positions,
Mm,
because a lot of moms, people who are working on other projects, and people who just may not be able to work a full-time job will be able to do amazing things for you. And most of your team's part-time, my team is entirely part-time.
hmm.
And so we're able to bring together these people that have a variety of dreams, that are pursuing a variety of different things they love, and are able to bring their love of space to the things that we do together.
Yeah, I think it burns out a person to write full time.
Yeah.
Like, for that to just be their job day in, day out. You sit down in front of the computer and you write and report all day long. But I think that a lot of people have in them an interest and a curiosity, and they want to express themselves in writing. And so I actually think that, as long as you make it worth people's while,
Yeah.
and that's the thing that I'm very proud about now, is that I am able to pay a very good wage to all of the people that work with me, and I let them decide how much they want to work. So if they only want to, I have a couple of people that only write 1 or 2 articles a month, and I have a few people that are writing uh, a couple a day.
Yeah.
And I think that you sort of take your time, find people, try them out, and build those relationships over time. Show that you have their best interests at heart, that you have science education's interests at heart. And like, it's interesting. Like, my job is to try to raise the profile of all of the writers who work with the universe today. Like, I really want to help them. So we put everything out in Creative Commons
Yeah.
4.0, so anyone can use our articles for any purpose they want. But all I ask is that the original author gets credited. So if you're going to take our article, just make sure that you give credit to the person who wrote it, and that will get their name out wider. And and I really feel like the more you can put that spotlight back on the individuals, the team, the more that you can help them build their career. And it's great. I mean, some of the biggest names in science journalists, in space science journalists, spent time working with the universe today. And I
Yes.
sort of feel like it's a badge of honor that Ian O'Neill and Amy Sherwood Titel and Alan Boyle and Nancy Atkinson and all these people. In some cases, they still maintain an orbit with us. In other cases, they've gone on to great things. And it's great to have just a great working relationship with all of them. That sort of, once you spend time in universe today, then your family.
Yeah. And it really is a amazing community where the philosophy that we've taken with Astronomy Cast, which we do together with CosmoQuest, with Universe Today, is give everything away.
Yeah.
Find ways to get it paid for, like what we're doing with this Hangout-a-thon. We have your patreon.com/universe today. We have the CosmoQuest Patreon. But just give everything away and teach people how to do what we do. And
Yeah.
and there's this base idea that we can raise up the world's understanding of space science, bring more people to our field by teaching more people how to be better science communicators.
Yeah, it's interesting. Like I don't know if you remember, you, me, and Phil Plait
Yeah,
had this kind of collective realization. Must have been almost, when we started Astronomy Cast,
yeah,
of just like there's no such thing as competition.
yeah,
That we could spend our entire careers just helping people out as quickly as we could,
yep,
um, and we would never have run into any kind of problem from and it's about helping the community, helping each other, helping other people get a leg up, helping teach people the ropes, give them a chance, help spread their message,
yeah,
whatever they're, if people have written articles, we can help them get the word out about what they're doing, help them, showcase them on the projects that we're working on. And it's never backfired.
yeah,
That it's just always been inclusive. It's always been um yeah, it's been great. And it's funny, it's felt like this core philosophy that we just assumed this was
yeah,
true back in the beginning, and it's remained true to this day. It's still, and still the names come and go. There's a pile of incredible new people um who have shown up on the scene, and I can't wait to help them grow what they're
yeah.
doing as well.
And what's always amazing to me is the way people come and go through the years, and the adventures they go on, and we all still come back together at the end of the day sharing our stories. Everyone but me sharing their asteroid numbers. I'm not bitter. There was actually, just to tell the story on the background behind this, there was one time it was you, Ian O'Neill, Phil Plait, I don't remember if Nancy Atkinson was there. It was a whole bunch of science communicators. And I don't know how we got to the topic. Rick Feinberg was there. But somehow everyone starts sharing the number of the asteroid that was named after them. And I was the only one there who didn't have an asteroid.
Oh,
I'm
you got to
still
discover it.
sad.
Soon as Vera Rubin comes online, you've got to dig through that data and use your programming skills and
I
discover your
can't
own
name an
asteroid.
asteroid after myself. You didn't discover the asteroid named
No, it's
after
true.
you.
No, no, no. So you need to, okay, so fine. So you need to discover one and then have someone on your team name it after you. You can figure out a way to make this happen. Vera Rubin's going to turn up a lot of asteroids. And so you're a programmer as well. So I think you're
It's
going to
true.
be well equipped to turn up your asteroid in the Vera Rubin data.
But for those of you joining us, this is the CosmoQuest Hangout-a-thon. We are in hour 13, which is apparently the hour when I forget how to stay on topic. We
What
are
are we doing here again?
we are here nominally, perhaps, potentially, to discuss the Great Observatories. My producer has just run away, I think, to let someone else in. Yes, we have an Annie Wilson, host of Rocket Roundup, has just arrived. There is a very tiny dog that has come with her. So the counting of the dogs is now 4 in this house. My producer is back. And I'm just going to say that we are currently sitting at. Um, Can you hit reload on Kindful?
Yes.
I'm trying to figure out where we're sitting in donations right now.
Currently sitting at reload.
We are currently at $9,524 in donations on Kindful. Over on Twitch, let's see if the software is willing to give us an update yet. I'm not sure it is. Twitch is being twitchy and it's not telling us exactly where we have. We are somewhere shy. Wait. I'm getting the hold on notice from my producer. I am holding. There's a number being written. Waiting. What is going on? So once we have this number, we are going to be going to Twitch is not updating. So without the Twitch update, we're sitting at $10,151.91. Now, we know that there's been significant contributions that came in through Twitch. Twitch is just not telling us yet. We're going to work on figuring that out in the background and hoping Twitch updates. But we are actually here to record a podcast.
Yes. Focus, Pamela. Focus.
So we are going to push back in time when we go to the Minecraft update so that we can do this, do this show real fast. So are you ready to press record, Allie?
Oh, I've been recording.
Okay, so apparently we're already recording. I didn't need to wait for my production.
Started recording.
All right, so Rich, audio editor for Astronomy Cast, we are very sorry for all of my audio you just got to listen to without any audio from Fraser.
I'm going to start recording now.
So, yeah. Here we go. So,
all right. You ready?
Yep.
Okay.
No commercials needed.
Okay. Astronomy Cast, episode 616, The Great Observatories. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. I have been streaming for almost 13 hours now. Some of you out there listening to this aren't watching live. We are recording this episode of Astronomy Cast during the 2021 Hangout-a-thon as we work to raise funds to keep all of our programs going. But we are taking this time to record a very special episode of Astronomy Cast on a topic I can't believe.
Episode.
Yeah, I can't believe we haven't done this yet.
Well, we've done it in pieces. So
sort of.
Yeah, I think we have. But yeah, I mean, to think 15 years we haven't talked about the Great Observatories. Now is their time.
Yes.
I mean, by your rules, I guess. I mean, they've launched. Some of them are still operating. So I think science has been delivered. So I think now it's fair. Now we're allowed to talk about them, right?
Yes, they've done more than return first light.
That's true. All right, well, you're familiar with the Hubble Space Telescope, of course, but it's just one of NASA's great observatories. After Hubble came 3 more incredible telescopes, each greater than the last. Actually, that's not true. The first one was the greatest. But together, they would fill in almost the entire electromagnetic spectrum. All right, Pamela, let's talk about the great observatories.
Where did we start?
Did they start? Did they name them before they launched them?
No. So
they named them after they launched them.
Yeah. So this is one of the things that those of us who are of a certain generation, I will say, we look at the fact that JWST, which I am just going to call JWST, we look to the fact that it was named what is now decades before it launched. And we're just like, you cursed it. You wait to name the telescope until it has first light. Yep. I was out at Sonoma State Observatory doing a workshop for GLAST, which is now the Fermi telescope, right after Fermi's launch. While I was there, they were getting back first light from the telescope. And they were corresponding with Fermi's family to be like, okay, so the telescope works. Everything's good. Are you down with us naming this telescope? And it was much more formal, much more dignified. But are you down with us naming this telescope after Enrique Fermi to celebrate his life and his discoveries? And that's the way I really think it should be.
Yeah, I 100% agree with you. The original name for James Webb was the Next Generation Space Telescope.
Yes.
And a name that I saw on Twitter that I really liked was the Very Cold Space Telescope. So I think I think you're exactly right. Give the telescope a working name that is very utilitarian,
Yeah.
and then when it achieves first light, when everything is done and safe, and then the spirit of the telescope arises in your mind, and then you give it its proper formal, but also like naming after a person
And
who's important.
my favorite headcanon of space telescopes comes from our producer, Allie, who at one point spontaneously said something along the lines of, "The reason JWST is so delayed is it doesn't even like its name and is waiting for a new one before it will
Right.
deliver the science."
Yeah, there you go. So let's talk about the great observatories. So what are they? Let's start with that. What are the great observatories?
So, the great observatories are the Hubble Space Telescope, the Compton X ray Observatory, the Spitzer Infrared Observatory, and of course, the Chandra X ray Observatory.
Uh, so and like, did they call them like so? Like, why did they call them the great observatories? Was it just because they were sort of launched around the same time?
No, it was actually a concerted effort to launch a suite of telescopes that would cover pretty much the entirety of the electromagnetic spectrum as we had the technology at the time to do it. We'd been looking, and by this I mean generations of astronomers before me, because I was not. My parents weren't even born yet. So back in the 1940s, folks realized that with space-based technology, we'd be able to get telescopes up above all the atmospheric noise and turbulence that distorts so many astronomical images. And from up there, we'd be able to make out details, fine structures we otherwise would never ever be able to see until we got adaptive optics, which was not yet imagined yet in the 1940s.
Right.
From this imagining of the optical telescope in space, it was simply a matter of time before people started thinking, we can't see X-rays from Earth. And oh, expletive. It turns out the universe is producing gamma rays, and we didn't know that. That was
Yeah.
discovered entirely by accident. Infrared blocked by our atmosphere. The only way we can see all of these different colors of light and get high resolution optical images with the technology we had back in the 40s, 70s, 80s was to put the telescopes in space.
It's interesting when you imagine the entire electromagnetic spectrum, and you've
We're
got
leaving out radio. I do have to acknowledge
right.
radio exists. We're doing that one from the ground.
Sure, yeah, yeah. But when you imagine, you start on the radio end of the spectrum, you got microwaves. Those work well with going through the Earth's atmosphere, and then you shift into infrared, far infrared, and even bits of near infrared, and it's really hard to go through the Earth's atmosphere. You got to get very cold. The Earth is hot. It's tough.
And
Visible light, sure, that works. Ultraviolet sort of works, but then at the
yeah.
higher ends, it's not going to work well. And then X-ray doesn't work, and gamma radiation. And so there were these just giant areas of the entire electromagnetic spectrum that we just couldn't see.
And the problems, the atmosphere that plagued the optical and then simply absorbed away all these admittedly harmful, bad for our health. We
Yeah,
don't really
yeah,
want them on the surface of our
yeah. They can
planet.
stay in space.
They can stay in space.
Yeah.
But us scientists, we'd like to be able to get to them, please. And that means orbiting
Yeah.
observatories.
I was talking with an astronomer from the Chandra X-ray Observatory, which we'll talk about in a little bit, and he was saying that the vast majority of the sort of interesting parts of the universe are in the radiation of X-rays. Like all of the
Yeah.
hot gas that's in between galaxies, a lot of just the large scale structure of the universe is only emitted in X-rays.
The
And
cores of
without
galaxies glow in X ray.
Yeah, and without X-rays, you really can't just understand the structure of the universe. And so we were blind to it
Yeah.
until we had a chance to be able to have it. So you've got these four observatories. what order did they launch in?
So here I have to admit, I have to look at my notes again. I've been streaming for 13 hours. So the Hubble went up in 1991. In 1990.
Yeah.
Compton went up in 91. Chandra in 99. And Spitzer in 2003. And for the most part, they were all expected to last on the order of 10 years, 15 years. Poor Spitzer, launched in 2003, was only slated through 2009 when it ran out of coolant to observe the longest of the infrared colors during its cold operations. But they found a way to keep Spitzer going until 2020, when it simply drifted too far away in its orbit for easy communications with Earth. These things were tanks, except for
Yeah.
Compton.
Yeah. So let's. I mean, even Compton went for a long time.
Yeah.
So we'll go in order of launch. So I mean, Hubble in 1990, of course.
Yeah.
We're very familiar. It was launched from the space shuttle.
Yes. And the
and that's a
original
theme.
plan was for all of them to launch on space shuttles.
Yeah. And 3 of them did. But and then of course we're all very familiar, I am assuming, with the big problem after Hubble launched in 1990.
And that big problem when Hubble launched was, and we talked about this briefly earlier today during the Hangout-a-thon, not that helps those of you listening to the podcast. When they were grinding the mirror for Hubble, they thought that they were using a specially placed focal point to focus the mirror while they ground it. And it turns out they were actually focusing on a fleck of something they weren't supposed to be focusing on. And as a result...
I never heard that story.
Yeah.
I didn't realize that's what was going on. So they were focusing on the wrong spot.
Yeah, and so they ended up with a perfectly ground mirror for the wrong optical system. But because it was a perfectly ground mirror for a different focal length, they had the ability to fix the Hubble by launching essentially corrective glasses. And so this correction system that they put up during a servicing mission, well, that was everything we needed to do all sorts of amazing science that studied planetary objects, found moons around Pluto before New Horizons got there, that is allowing us to explore the first galaxies forming in our universe through gravitational lenses. It's an absolutely amazing set of science that it's done through my entire adult life.
Yeah. It is still incredible. For the other missions, we'll talk about when they may or may not have ended.
Yeah.
2 are still working, 2 have ended. But I mean, just Hubble was first in and could very well be last out. That we're already 32 years into operation with Hubble. It has changed our understanding of the universe in ways that nobody had ever predicted, and yet it is still going strong. It is oversubscribed. Every year, astronomers line up to use Hubble, and it is still providing some of our best images
And
ever.
One of the weirdest facts about the fact that it's still up there and working is it's still up there and working because we still don't have the JWST. The original plan was both telescopes are going to be run out of the Space Telescope Institute in Baltimore. And I remember attending talks in 2007, 2008, where they were talking about, with JWST, the budget is such that they can't operate both telescopes at the same time. So had JWST launched as planned in the early 2000s, it was supposed to be up in 2009 when Spitzer was out of its
Right.
coolant. had Hubble been up in 2009, we wouldn't have had, not Hubble, had JWST been up during 2009, we wouldn't have had that final servicing mission that brought that last great suite of instruments that we continue to use today.
Yeah, and so, you know, there probably will not be, almost certainly will not be another servicing mission unless like Starship gets really good, really
That would be
fast.
amazing, by the
And they would
way.
just go and gulp up Hubble and bring it back down to Earth. They can make all the improvements and then send it back up. That would be great. But I think otherwise, you know, maybe Hubble has another 10 years in it before it will finally wear down and it's time to deorbit it. So that's Hubble, the one we're most familiar with. Let's talk about the one that we're probably least familiar with, but went next, which was the Compton Gamma Ray Observatory.
Yeah.
So what was its job?
So its job was to allow us to finally get a really good understanding of this really weird wavelength of light that we hadn't, as a profession, initially thought was going to be scientifically interesting. This is the gamma rays, the shortest wavelengths of light, the hottest, emitted by the hottest and most energetic things in the universe. And one of my favorite moments with Compton was it was out there observing gamma ray burst 990123. Now, up until this point, we knew that there were short gamma ray bursts that were just bleeps in the night, fractions of a second. We knew that there were longer ones that were minutes, tens of minutes in a few cases. There was a continuum with a big old dip in between. But we had no idea what gamma ray bursts were. We didn't actually know if they were actually in our galaxy or beyond. And it was with that GRB 990123 that we finally saw an optical counterpart for the first time. So Compton was there observing the gamma rays going, hey, folks, over here, look over here. And we were able to get enough telescopes in the correct part of the sky to figure out what new thing was shining in the night. And this started us down the path of figuring out that gamma ray bursts are associated with certain kinds of exploding stars that we now refer to as hypernovae.
Right. And just like, because these things explode so quickly, it was really tricky to bring Compton to bear on the target in time. And in fact, that idea of quickly responding, other gamma ray observatories came afterwards that were highly specialized for being able to find these objects within a minute of when they exploded. But it's quite a feat to be able to make these observations that early and provide those details. And before that, like, people had theories, but they really had no idea of what was causing these gamma ray bursts. It was a ludicrous amount of energy was being blasted, almost like a laser beam, across the universe. So much energy that you could be on the other side of the Milky Way and be hit by a gamma ray burst and have your atmosphere blasted off of your planet. So the fact that they were able to make these kinds of discoveries, and that was just one. I mean, there was many more incredible accomplishments that Compton, but I think you're right. That was one of the big ones. Let's talk about Chandra, because Chandra went next.
Chandra, there's no end to what this telescope is able to really accomplish. And the amazing thing about Chandra is it's not in the orbit it was originally intended to be in. They got everything working perfectly. It is on an elliptical orbit that carries it out beyond the Earth's Van Allen radiation belts, brings it back down, and orbit after orbit, it's out there looking at the hot gas that fills the center of galaxy clusters. It's out there identifying the crackles of high energy radiation around pulsars in the vicinity of white dwarfs that are parts of systems where the white dwarfs are cannibalizing material off of their sister and brother stars. There is all this dynamic, often destructive physics out there that we see through these X-rays.
Yeah, like the regions around supermassive black holes,
Yes.
as you say, the afterglow of exploded stars, the the high energy interactions between uh, solar flares and their planets. Like it's it's kind of amazing. And again, as I said, in the minds of X-ray astronomers, it's it's the way the universe really looks. We're spoiled, we see in the visible light, but that's not how the universe truly looks. If you
And
could see the whole spectrum, it would be the X-rays that are just blasting.
and this brings us to one of the things that Chandra does in partnership with the other observatories, but they're the ones out there putting everything together, is month after month, year after year, going on decade after decade, Chandra has been doing these deep observations in the X-ray of all sorts of different phenomena. We have seen Chandra mosaics of supernovae, of
Hmm.
galaxies, and they'll put out press releases that bring together Hubble images, that bring together Spitzer images, and their own Chandra images to show us this false to our eyes color image of what the universe would look like were we able to enjoy the entirety of the electromagnetic spectrum. And just I think it was last week there was an amazing supernova remnant that they
Yeah.
came out with, an object that went off. I want to say thousands of years ago. I'm too
Yeah.
tired to remember exactly when. But now we can see it expanding and colliding with the gas around it, and it's just beautiful.
Well, and you sort of ruined my conclusion here, but because we were going to talk about Spitzer, but one of the things that really did tie together this idea of these observatories working as a unit
Yeah.
were these images, some produced by Chandra, but also like some were released with Hubble, where they would take a series of images using, say, the Hubble Space Telescope, and then they would also observe the same region in X-rays or in with Spitzer in infrared, and then put them all together with different colors, and then you could see this is the stuff that is incredibly hot and bright, and then this is the stuff that would look as if we saw with our own eyes, and then this is the clouds of dust that's obscuring other parts from our point of view. And that's what I think is the real take home about having this access to the entire electromagnetic spectrum, is now suddenly you see the stuff that you would normally see, but you also see all the stuff that you wouldn't see, that's invisible, and each one tells a different story.
And we got lucky that when Compton failed, they were already thinking ahead to GLAST, which became Fermi, to Swift, which fills a different role doing its images looking specifically for gamma ray bursts and targeting their location using its many different wavelength detectors. There was this vision moving ahead of how we would fill in behind. And so Fermi stepped forward, filled the role of
Hmm.
Compton. Someday JWST will step forward and fill in that role that Spitzer had, bringing us, well, as Fermi brought us so much better views of the gamma ray universe, so too will hopefully someday maybe JWST bring us better images than Spitzer. Now,
But not quite,
yeah,
because because Spitzer was colder, and so Spitzer could see farther into the infrared than James Webb will be able to. James Webb doesn't have that coolant on board. It just has that incredible sun shield to
Right.
block the light from the sun. But Spitzer, like, there is nothing that can compare to Spitzer out there. I mean, apart from maybe ESA's Herschel mission, which sort of fulfilled the same kind of role. And the real successor to Spitzer is going to be like Habex, or there's new missions in the works. It will be the true successor. So so let's talk briefly about Spitzer before we run out of time. That was the last of the Great Observatories to launch in 2000.
2003.
2003. Right.
And
the
it was
year we started Astronomy Cast? No, wait.
No,
Yeah.
we started in 2005. So
2005. Okay.
no,
Yeah,
no,
sorry.
Slacker Astronomy was 2005. We were 2006.
Okay.
Podcasting started in 2004, so we did not launch with
Right.
Spitzer.
Did not launch with Spitzer. Yeah. Okay.
So Spitzer launched in 2003. It was an infrared observatory seeing those colors of light that, the Terminator uses to figure out where people are inside buildings while looking for their heat. This is a
Right.
color of light we can't see, but some insects and reptiles can. It went into colors of light even redder than what anything alive on our planet can see. And with those eyes, it was able to peer through clouds of gas, seeing all the stars that lurked behind, because it turns out it's the short wavelengths of light that dust is able to stop. And those longer wavelengths, those redder wavelengths, are able to pass through. So there's these amazing images of things like the Pillars of Creation, one of those canonical nebula that you've seen in everything from Star Trek to coffee mugs.
Yeah.
There's images taken with Spitzer where they appeared as nothing more than ghosts with stars shining through their structure.
I think the most impactful images that I'd ever seen from Spitzer, there was incredible images of seeing through nebula because you can see into the dust. But the one that really hit me the hardest was the view of the Milky Way. There's an incredible mosaic taken by Spitzer of the entire Milky Way. And the image is gorgeous, just beautiful. But also, because Spitzer could see through the gas and dust of the Milky Way, it allowed astronomers to actually start to see what was behind the disk of the Milky Way for the first time, that we had never known. There's always the great attractor. What is this mystery? And we could finally see it. We could finally see the galaxies that were over there that were helping to sort of summon us and a lot of galaxies towards this center of gravity.
And I have to giggle every time I think of that image, because one of the side effects of being able to see through all but the thickest gas and dust out there was we learned that our galaxy is sitting out there blowing bubbles left and right. There are all these beautiful spherical pockets blown empty that we're just waiting to be discovered, that are related to different parts of star formation.
And so we should talk about their endings.
Yeah.
Hubble, of course, still going.
Yes.
Chandra still going.
Yes.
When did we lose Compton?
Compton died, fairly early. And it had the saddest and most common fate a spacecraft can have.
I wonder what it could be.
Yeah, so
what could have taken it out?
Back in 2000, when I was still a graduate student, it lost a gyroscope. Only one, it still had others. But the concern was that Compton was a dense enough spacecraft that if it came plowing uncontrolled through the atmosphere, chunks of it could do damage to something on the surface of this planet. And having dumped bits of spacecraft on Australia and having still found ourselves getting made fun of it, we weren't looking forward to dumping more spacecraft on potentially other nations. So the decision was made for the first time in NASA's history to purposefully deorbit a spacecraft because they weren't sure they could control the telescope with only one gyroscope. So down she came.
Yeah. And I wonder though, like later on, they figured out how to control telescopes with down a gyroscope, and so I wonder if they could have used some of that same methodology because,
Yeah.
say, Kepler, they were able to figure it out. So when did we lose Spitzer?
So Spitzer, for all we know, may still be a tired, healthy, low energy spacecraft still lagging behind us. Spitzer was put into a really cool orbit that was super similar to Earth's orbit, but not identical. And as a result, over time, Earth crept ahead around the sun, Spitzer lagged behind, orbiting the sun, and the two missions, because of their different paces, ended up going further and further apart as they circled and circled through the years. And Spitzer just was really struggling to make itself heard here on Earth when they gave up science missions just last year.
Yeah, so we were in Hawaii for the AAS meeting when they sort of did the final announcement, did the
Yeah.
final discussion about Spitzer, talking, sort of doing a, I guess, a post-mortem talking
Yeah.
about it. It was really sad because it, as I said, like it produced images like the Chandra images were nice, but in many cases they were best when they were overlaid on top of a Hubble picture or a
Right.
Spitzer picture.
X-rays are
And
not exciting people unless you think about how high
yeah,
energy they are. You don't
yeah,
get detailed details, for
yeah,
lack of a better set of words, when you're looking at things that are simply sitting there blasting energy into the
yeah.
universe.
So I came up with a way to talk about how we detect the electromagnetic spectrum, which sort of thinking about the various observatories. So when you hold out your hands to feel the heat coming from, say, a a nuclear reactor, um, then that's you're sensing
Do
the
not try
infrared.
this at home
Do not try this at home. And then, of course, you can see it. You can see the nuclear reactor with your own eyes.
before
Um,
they
yep. As you
melt.
get, right, as you get the burns on your skin, the sunburns, uh, then then essentially your skin is an ultraviolet detector. And then I guess when the cancer shows up later on, that's you detecting the X-rays. So it's pretty gross,
I don't like this analogy.
right, but that's the way we could detect all of these wavelengths all at the same time. Um,
No.
well, thank you, Pamela. It's funny. I just like my career in science journalism really went along with reporting on all of these observatories. Hubble had already launched, I guess, and Compton had already launched, but I was there for Chandra, I was there for
Yeah.
Spitzer, and there for the end of all of them. Hopefully, I'll be there for the end of the last two and sort of really get a chance
Yeah.
to see them through their entire life. It's been
It's
what
been an
wonderful
amazing journey.
machines. Yeah,
We
yeah,
were the children of Voyager and the adults of the Great Observatories.
yeah, yeah. All right. Well, thank you, Pamela, and we'll see you tomorrow for the next
Yes,
episode.
yes, you will. So thank you so much, Fraser. And this is the point in the story when we would normally pause to thank all of our patrons. I will be going back and recording that thanks after the fact. And this is your chance to go and join our Patreon, patreon.com/astronomycast. But we are really here right
Should I
now.
stop my recording now?
Yeah, go ahead.